2 days ago, something from space hit Earth, and nobody saw it coming. On Sunday evening, March 8th, at 6:55 p.m. Central European Time, a fireball tore across the skies of 5 countries: Belgium, France, Germany, Luxembourg, the Netherlands. Millions of people looked up, dash cams captured it, security cameras recorded it. The object glowed for 6 seconds, brighter than anything natural should glow, before it shattered into pieces. And then, in the small German town of Koblenz-Gulz, fragments punched through the atmosphere and struck at least one house. The European Space Agency confirmed the impact within hours. They're still analyzing the data, but their preliminary estimate puts the object at several meters in diameter. That's roughly the size of a car, maybe bigger. Here's what should concern you. Not a single telescope on Earth detected it before it arrived. This wasn't some rare, impossible scenario. According to ESA's own records, humanity has successfully predicted an asteroid impact before it happened exactly 11 times. Ever, in all of human history. The March 8th fireball was not one of them. It approached from the direction of the setting sun, from what astronomers call the day side of Earth, where the glare makes detection nearly impossible. Our most advanced warning systems were completely blind. But here's where this gets personal for every single person watching this. Remember Chelyabinsk? February 15, 2013. A 20-meter asteroid, about the size of a 6-story building, exploded over Russia with the force of 30 Hiroshima bombs. The shockwave shattered windows across 6 cities, 7,200 buildings damaged, over 500 people injured, mostly from flying glass. Some suffered temporary blindness just from looking at the flash. That asteroid also came from the direction of the sun. Nobody saw it coming either. The Chelyabinsk meteor was 13 years ago. Since then, we've launched missions to deflect asteroids, we've built new telescopes, we've held international conferences, we've created coordination centers. And yet, in 2026, an object can still enter our atmosphere without any warning whatsoever and hit someone's house in Germany. What went wrong? More importantly, what are we actually doing about it? The uncomfortable truth is that our current planetary defense infrastructure has a massive blind spot. Ground-based telescopes can only see objects that are illuminated by the sun while Earth's surface is in darkness. Think about what that means. Any asteroid approaching from roughly the same direction as the sun is essentially invisible until it's already entering the atmosphere. The window for detection might be hours, or minutes, or nothing at all. ESA knows this, NASA knows this. The problem isn't ignorance. The problem is that fixing it requires putting telescopes in space between Earth and the sun where they can spot these hidden threats. ESA has proposed exactly such a mission called NEO-MIR, designed to hunt asteroids in infrared wavelengths that aren't washed out by sunlight. But NEO-MIR isn't scheduled to launch until the mid-2030s. Meanwhile, ESA just deployed their new FlyEye telescope in Italy last year. It's an impressive piece of engineering designed like an insect's compound eye to scan huge portions of the night sky automatically. But notice that phrase, night sky. FlyEye can see objects approaching from the dark side of Earth. The March 8th fireball came from the opposite direction. Now, here's what no one is talking about. The object that hit Germany was estimated at several meters across. It damaged property but caused no reported injuries. That's fortunate. But Chelyabinsk was 20 meters, only about 4 to 5 times larger, and it injured 1,500 people. The relationship between size and destruction isn't linear. A slightly bigger rock doesn't cause slightly more damage. It causes exponentially more. An asteroid 50 meters across, about half a football field, could flatten a city. At 140 meters, you're looking at regional devastation. At a kilometer, you're talking about global catastrophe, mass extinction territory. The Chicxulub asteroid that killed the dinosaurs was roughly 10 kilometers wide. Here's the statistical reality that keeps planetary defense scientists awake at night. Objects in the Chelyabinsk size range, around 20 meters, are estimated to hit Earth roughly once every 60 years on average. But that's an average. These events don't follow a schedule. The last 2 major ones, Chelyabinsk in 2013 and the March 8th event in 2026, happened only 13 years apart. We could go another century without a significant impact, or we could have one next month. And this is where it gets genuinely unsettling. Scientists estimate that we've cataloged less than half of the near-Earth asteroids larger than 140 meters, the threshold for regional destruction. For objects in the 50-meter range, the city killer category, we've found perhaps 10%. For objects the size of Chelyabinsk, we've barely scratched the surface. There could be tens of thousands of them orbiting the sun, occasionally crossing Earth's path, completely unknown to us. The March 8th fireball should be a wake-up call, not because it caused catastrophic damage, but because it proved that our detection capabilities remain fundamentally incomplete. A rock the size of a car entered our atmosphere at thousands of miles per hour, crossed multiple national borders, struck a building in a quiet German neighborhood, and our entire global early warning system, the combined efforts of every space agency on Earth, provided zero advance notice. The families in Koblenz Gulls didn't get an alert. There was no evacuation order, no time to take shelter. The first indication that anything was happening was a streak of light across the sky, followed by pieces of space rock coming through their roof. What happens when the next one is bigger? After Chelyabinsk, there was global alarm, congressional hearings were held, new funding was proposed, coordination improved. But then the years passed. Other priorities emerged. The sense of urgency faded. Now we have another reminder, smaller this time, delivered directly to someone's doorstep in Germany. The technology to close this gap exists. Space-based infrared telescopes could detect sun-approaching asteroids weeks or months in advance. Faster response spacecraft could be developed to deflect smaller objects on short notice. International protocols could be strengthened for rapid evacuation if necessary. None of this is science fiction. All of it requires sustained investment and political will. ESA's response to the March 8th event has been professional and transparent. They're analyzing the data, coordinating with the global network, and working to characterize what happened. But analysis after the fact isn't protection. The families in that house in Koblenz Gulls didn't receive a warning. They discovered the threat when pieces came through their roof. We've spent decades dreaming about becoming a multi-planetary species, colonizing Mars, mining asteroids, expanding into the cosmos, but we still can't protect the one planet we live on from rocks that appear from the direction of the sun with no warning. The March 8th fireball wasn't a catastrophe, it was a message. Whether we choose to hear it is up to us. If you had 72 hours warning that an asteroid was coming, what would you do? What should governments do? That's the question planetary defense is actually about. And right now, for objects approaching from certain directions, we might not even get 72 seconds.